Hi, I am Tom Christensen of Neurochrome. In this build video, I will show you how to build one of these Modulus-286 power amplifiers. It provides 65 watts into 8 ohms and 125 watts into 4 ohms. The power comes in through this 300 VA power transformer. It provides two windings of 25 volts, which go to the power 686. At the Neurochrome power 686, it is rectified and turned into plus minus 35 volts. That goes to the Neurochrome Modulus-286 amplifier modules. Speaker protection is provided by the Neurochrome Guardian 86, and the whole shebang is controlled with this Neurochrome Intelligent Soft Start. The Intelligent Soft Start, or ISS for short, also allows you to have this neat 12 volt trigger input. And that allows for remote control of this amplifier if your preamp has a trigger output. The amplifier has balanced inputs on these Xlr connectors. If you would rather build it with RCA connectors instead, you can. Neutrik makes a connector that mounts in this exact location. Outputs of the amplifier are provided on these Neutrik Speakons as well as on the binding posts. And by the way, if you would rather have the Modulus-186, which offers slightly lower power, just keep watching this build video because the build is basically only different by 2 screws and a couple of details around the power supply. If you would rather have the chassis in black, I offer that option as well. It looks pretty darn stunning in my opinion, although I kind of like both. But if black suits your fancy, go ahead and order the black chassis instead. The build process is the same. The star of the show in this build video is the Modulus-286. It is available as a fully assembled module as is shown here. Each of these amplifier modules provides 65 watts into 8 ohms and 125 watts into 4 ohms when powered by a power supply in the range of plus minus 35 to plus minus 36 volts. The two main differences between a Modulus-186 amplifier build and a Modulus-286 amplifier build is 1. The amplifier module itself. Of course, you'll want the Modulus-186 amplifier modules if you're building the 186, and the 286 modules for the 286. The second difference is the power supply. For the Modulus-186, I generally recommend that you go with a power 86 and a 200 VA power transformer that provides 2 windings of 22 volts AC. For the Modulus-286, which I will show in this build video, I am going with the power 686. It has twice the capacitance of the power 86, and it is shown right here. It is available as a bare board that you buy parts for and assemble yourself, and it's also available as a fully assembled modules as shown here. I will power it with a power transformer that provides 2 windings of 25 volts AC and 300 VA. That with the power 686 will give you about plus minus 35 volts rectified, which is the voltage needed to get the specified output power from the Modulus-286. To control the mains power going into the power transformer, I use a Neurochrome Intelligent Soft Start, or ISS for short. That is this circuit shown right here. It comes with these parts, and they're used to select the mains voltage for the power transformer. The advantage of using a soft start circuit is that it limits the inrush current of the power transformer. That in turn limits the mechanical stresses that the power transformer is exposed to on startup, and limiting those stresses will cause the transformer to last longer. In addition, the Neurochrome Intelligent Soft Start offers a range of convenient features such as LED dimmers, support for multiple different types of power switches, etc. For more information, see the Intelligent Soft Start product page. And also, if you're curious about soft start design in general, I highly recommend that you check out my website called The Ultimate Guide to Soft Start Design. In this particular build, I will be including the Guardian 86 speaker protection circuit. I consider speaker protection to be mandatory in a retail amplifier, and I'll be selling this amplifier after I'm done building it. In a DIY amplifier, I would consider speaker protection to be optional. Basically, it comes down to the odds of the amplifier failing, the cost of your speakers, and how well do you want to sleep at night. And it's very unlikely that the Modulus-286 or any amplifier that I offer will fail. But no odds are zero, of course. So basically, the important thing is here that if you do choose to go with a speaker protection circuit, choose one that is acoustically or sonically transparent when it is running, and that will protect your speakers in the event that the amplifier fails. And the Guardian 86 does exactly that. To build this amp, you need some hand tools. You'll need some Phillips screwdrivers, number 1, number 2 size. You'll need some flat blade screwdrivers ranging in width from 2 millimeters to about 5 millimeters. You'll need some Torx screwdrivers. This is a Torx T10, this is a T20. This guy here is a Torx Plus screwdriver. There are a couple of screws on the rear panel that requires it, but don't stress too much if you don't have Torx Plus, because those screws turn just fine with a regular Torx screwdriver, a T10 in that case. These guys are nut drivers. I like using nut drivers. It makes it easier for me to handle the little hex nuts that are part of this project. If you have a socket wrench set, you'll probably find you have something like this. And you'll likely find that you have the correct sizes. You'll need a 4.5, a 5.5, and a 7 millimeter. You need to be able to make a reliable crimp on a spade terminal. For that, I highly recommend getting a ratcheting crimper like this. This particular one is by Molex. It's actually not terribly expensive, but it makes a very reliable crimp connection every time. In addition, you'll need a utility knife, a couple of adjustable wrenches. You need to cover up to about 20 millimeters. I like using a scribe for prying apart the strands in a shielded cable. And these are wire strippers. You'll need a pair of pliers, and you'll need a pair of side cutters. A heat gun and some heat shrink in various colors and sizes can be handy. You will need to solder in a couple of places in this amplifier. So you'll need a soldering iron, and you'll need some solder. And if you have questions about which solder to choose, I recommend that you read the page titled Choosing Solder on my website. You'll need some wire. I use 16 gauge on the output of the amp. 16 gauge is 1.5 square millimeters. I use 20 gauge or 0.5 square millimeters everywhere else. I get it in a couple of different colors just so I can tell them apart, but you could easily tell them apart by coloring them with electrical tape or with colored heat shrink. And you'll need some thermal compound. This stuff here is Wakefield 120. Wakefield 126 works well as well. You might also be able to find some Arctic silver or similar at a local computer repair place. And finally, you'll need some microphone cable with 2 conductors and 1 shield. You'll need about, this much of it, so 50-60 centimeters thereabout. You can find the Modulus chassis on my website in the parts and connectors section. It arrives in a sturdy cardboard box like this, and inside you will find the chassis braced by a couple of foam end caps. I hope you will hang on to the box and the foam caps. That'll allow you to ship the amplifier without damage in the future. Included with the chassis, you will find a box of feet and a couple of bags of hardware. Let's start by removing the 6 screws that hold the top and the 6 screws that hold the bottom. Next up are the 4 screws that hold the chassis together on the top and the 4 screws on the bottom. You do want to be a little bit careful that you don't get these screws mixed up with the ones that you just removed from the top and bottom panel. That's because the outside screws have oval heads. So if you look at the head of the screw, you'll see it actually has a slightly dome profile, whereas these are completely flat heads. So you want the flat heads on the inside of the chassis, because if you put the oval heads in, the top and bottom panel will bow a little in the corner and that looks silly. Like that. Now we can take the chassis apart. Be careful not to scratch the aluminum surface. I will start with the front panel. It has one component in it, and that is the power switch. The power switch has a nut, and it has an O-ring as well as the switch itself. The O-ring needs to be applied over the threads and rolled up to the front of the switch, as I've done here. Then you just drop the switch into the hole in the front panel, apply the nut, and tighten with an adjustable wrench. Like so. The rear panel is a bit more involved. It has two Xlr connectors for the inputs, two Speakon connectors, and two pairs of binding posts for the output. It has a TRS jack for the trigger input, and it has an IEC mains inlet. The two Speakon connectors are attached with M3 machine screws that are 10 millimeters in length. Those are these guys. Everything else is attached with M3 machine screws that are 6 millimeters in length. Those are these guys. They're all flathead screws. The TRS jack from Switchcraft does come with two screws in the bag of its own. Toss those. They are US number 4s, and if you try to jam them into these metric threads, you'll ruin the threads. I'm a big fan of the Neurochrome Speakon connectors. They have been used for decades in the pro audio industry, and they're finally getting some traction in the audiophile community as well. The reason I like them is pretty simple. I mean, these are 4-pole connectors, meaning that they make 4 connections at once. Each pole is rated for 30 amps of current, and they're impossible to connect wrong. You just plug them in, turn, and they lock in place like that. I just made 4 connections all at once. None of them got crossed. All of them got connected correctly. And they don't come apart if somebody tugs on the cable. If I want to take these apart, just pull the latch and unplug. The binding posts consist of the binding post itself, a shoulder washer, a flat washer, a solder lug, a lock washer, and a nut. To attach these to the rear panel, grab the panel, and put the shoulder washer and the binding post through like that. Then drop in the flat washer and make sure it goes into this counter bore that's on the back side of the panel. Then the solder lug, lock washer, and the nut. I prefer to have the solder lug facing up like that. Make sure that the hole that goes through the binding post is vertical. I do that by inserting a small screwdriver into that hole, and you can sort of see this is about where I want it. The edges of the hole causes roughly equal excursion on the screwdriver. And then what I do is I turn it upside down and then tighten the nut on the inside using a 7mm nut driver. If the binding post does turn on you, like it has done here, you can always just pry it a little bit with a screwdriver until the hole is vertical. Next up are the Speakon connectors. They attach with the M3 10mm long flathead black machine screws. So the outputs are marked on the panel, so you just drop in the connector and attach with a M3x10 like so. Be careful that the screwdriver doesn't slip, because it is possible to scratch the surface of the aluminum or to remove some of the silk screen legend. Like that. The rest of the connectors attach with M3x6mm long machine screws. By default, all my amplifiers have balanced inputs. If you prefer to have unbalanced inputs, you can use RCA connectors instead of the Xlr connectors. Neurochrome makes an RCA connector that drops into the exact same mounting hole and attaches with the same screws as the Xlr connector. I do recommend that you build your amp with a balanced input though. You can always use a pseudo-balanced connection such as the pseudo-balanced or pseudo-differential cable that I show on my website. Next up is the wiring of the rear panel. The first thing that needs to happen is that pin 1 on each of the Xlr connectors needs to connect to the chassis. That happens at this chassis connector, this tab right here. And I find the easiest way to get those connected is to use a bit of resistor lead. So the component lead here, and I just take the end of it and I bend it over a little more than 90 degrees. And I thread it through the chassis tab and work it into pin 1 of the connector like so, and then just fold the lead over like that. And now we solder. Like that. Next, you'll need a couple of pieces of microphone cable. This is probably 25 centimeters, give or take. It's probably way too long, and that's fine. It's usually better to have more cable than not enough because they're difficult to extend. So what I'm going to do is I'm going to strip off about 20 millimeters of the outer jacket of this cable. And I'll do that with a utility knife. I just slice through and score through about half of the depth of the outer jacket. And then you can bend the cable over like so, and then just touch the plastic and it'll split right apart like that and like that. You don't want to nick the wires that are part of the shield because then they tend to fall off and make a mess. And it looks like I cut just a little bit at a crooked angle here. There we go. So now it is possible to remove the outer jacket like that. Next, I need to separate the shield wires. And I like using a scribe for that. I just sort of work the scribe in between the wires here and gently unbraid them. And the trick is to do this without causing the wires to fray. Because there's always going to be that one loose wire strand that ends up in the place that you really don't want it. So keep track of those. Oops, see, there's one. I'm going to throw that in the garbage in a moment. And now we have the wires stripped. Oh, there's another one. Now I twist the shield wires together. And I will just quickly tin the end of that to keep those wires together. There. Like that. Now all that's left is to remove all this cloth and paper material that's inside the cable. Just snip that off and toss in the garbage. Next, I apply a little bit of heat shrink to the shield just so that it doesn't accidentally come into contact with something. And let's just do that. Next up is stripping the wire ends here on the two signal wires. I'll just take the insulation off and twist the strands together, and I will just tin the ends here. Like that. And now it's time to solder it to the Xlr connector. It can be a little unwieldy to hold the panel and the cable and everything all at once. So I use one of these clamps that you can buy at your home improvement warehouse for not that much money. Just beware that if you get these kinds, that these plastic ends, they do tend to develop cracks over time, so just make sure you slide them up so you have plastic between the panel and the clamp itself, so you don't scratch the panel. So the connections on the Xlr connectors are as follows. The shield goes to pin 1, the hot wire goes to pin 2, and the cold is pin 3. I use blue for cold because blue reminds me of cold, but it's not like the electrons care, and I'm not really sure there's a standard. So use whatever you're comfortable with as long as you can keep track of it. So I'll start with the shield. I'll put that into pin 1, like so, and solder. Like that. And then for pins 2 and 3, I'll just tin the solder cup. Just give it a little bit of tin, like that, and that. The pin numbers are marked on the back of the connector, so you can always tell that way. Then I just take the cold wire, put it on pin 3, and quickly solder it. And the solder did miraculously harden before, or solidify before the panel toppled over, so that's good. And then pin 2. Like that. Now what I like to do is to take a bit of heat shrink of larger diameter and drape it over the outside, because there's usually a little bit of exposed shield down here. And I just want to make sure that's covered so that it doesn't accidentally come into contact with something. So I'll do that. The second Xlr connector is connected just as the first. So with this connected, it's now time for the speaker outputs. As mentioned earlier, I use both binding posts and Speakon connectors. And I really only support the binding posts because that's what the audiophile market wants. It's really not that great of a connector. The Speakons are much better. And I take advantage of the fact that these are 4-pole connectors. So on both of these connectors, I will have pole pair number 1, so 1 plus and minus. That will be left and right channel, respectively. And then on one of the connectors, I bring out both the channels. So pair 1 will have the right channel plus and minus, and pair 2 will have the left channel plus and minus. This allows me to easily make a vertical biamp, because basically you connect a 4-conductor speaker cable to the speaker and you plug it straight into this Speakon connector, and bam, you have a vertical biamp. Now let's get the binding posts and the Speakons wired up. For that, I use this 16 gauge wire. I only bothered to buy black wire. I think the other colors were out of stock or something. So I'll use black wire and I'll color it with some colored heat shrink so you can tell them apart in the video. And also so I can tell them apart when I hook it up. So the first step here is to take, I sort of eyeball it. So I want to connect pair 1 plus, which is here, with the red binding post. So I need about that much cable, or wire rather. I need this much wire. So I'll just cut that and strip the ends. That. And then I need a piece that connects to the amplifier. I don't know exactly how much, but it's not going to be longer than the chassis, so I mean, this is plenty. It's always better to have too much than too little. So then I strip that as well. that, and put them into the binding post, the solder lug here. Like so. Ta-da. And solder. And now I just need to repeat for the other binding posts. I now have a short piece and a long piece of wire connected to each of the binding posts. I'm going to cut the short pieces to length now. So I know that these two will go over to this Speakon connector. So I'm just going to trim them to length. Like that. This is the right channel Speakon connector. It needs to connect to the right side binding post, and it also needs to connect with a longer wire to the left side Speakon output to pull pair 2, because that becomes part of the biamp feature. So let's do that. I have a piece of wire prepared here, so I will just join those two together and work them into a it looks like I need to strip off a little bit more. You just want the wire to just poke through on the crimp terminal here, so like that. And now for the crimp. Like that. And now I just repeat for the rest of the connections. I now have crimp terminals on all the wires. In the cases where I have two 16 gauge wires that join together like this, I use the yellow terminals. They're intended for 12 to 14 gauge, so two 16 gauge should be fine. In the cases where I just have one 16 gauge wire, I use a blue terminal. Those are intended for 14 to 16 gauge wires. Now all I have to do is color the terminals with some colored heat shrink so we can tell them apart and get everything connected up. With heat shrink applied to the crimp terminals, it's now time to plug them in. I realize it's a bit confusing when I refer to left and right, and it's actually reverse of what you're seeing in the video, and that's because the panel is upside down. So this is actually the right channel output, and this is the left channel output. So let's get it hooked up. I'll start with the wire that comes from the binding post. That needs to go to this is the plus marked with red. It needs to go to pair 1 plus on the right side connector. As with the Xlr connectors, the pin numbers are marked on the back of the connector, and that makes it really easy. So binding post plus goes to pair 1 plus. Binding post minus goes to 1 minus. And then these are for the bi-wire or bi-amp connections. So the plus goes to pair 2 plus on the left side output, like that. And the minus, let's see if I can untangle them here, goes to 2 minus. And that is, oh come on, this guy. Then all I need is the left side binding posts. The plus goes to pair 1 plus, which is this terminal. And the minus goes to 1 minus. Which is that terminal. Just like that. The final connections on the rear panel are the ones for the mains and the ones for the trigger input. The mains connections are connected on the back of the IEC inlet, so that's this guy here, and the terminal here in the middle is ground or protective earth. This terminal here is neutral, marked with an N. This is live, marked with an L. This is the trigger jack, and one of those terminals is marked with a T, and that appears to be this one right here. So that goes to the tip of the jack. So that is trigger plus. The ring here, or this color, is connected to the sleeve of the jack, and that is also connected to this terminal here, and that is for trigger minus. So just like that, I have the mains connected with white for neutral, black for live, and the yellow-green for ground. As a little bit of an extra safety, I added some heat shrink over the terminals on the back of the IEC connector. It's generally a good thing to not have exposed mains connections inside of your chassis. For the trigger, I used orange for trigger plus and blue for trigger minus. It's now time to wire up the front panel switch. I will use brown for the switch itself, red for the red LED anode, green for the green LED anode that's inside the power switch. This is just 20 gauge wire, nothing fancy. If you look at the back of the switch, you will notice it has 4 terminals. 2 of them are gold plated and 2 of them are tin plated. The 2 gold plated ones are for the switch itself. So let's get the brown wires connected to that. And now for the LED connections. So I prefer the red-green version, so it has a red LED and a green LED in anti-parallel inside the power switch. I use red to indicate standby and green to indicate power on. So we need to figure out which pin here is connected to the red anode and which is connected to the anode of the green LED. So the anode of the red LED is marked by some writing on the side of the switch. It says R1.8 V+. That R stands for red. And on the other side it says G2.8 V-. I'm not sure why they use the minus because it's actually the anode of the green LED. So I connect a red wire to the anode of the red LED and a green wire to the anode of the green LED. And just like that. These are all low voltage connections. That's actually one of the advantages of the intelligent soft start. Because these are low voltage connections, they don't really need heat shrink. You can put some on if you feel like it, but it's not necessary. And also, the low voltage control greatly expands the options for power switches in that you can use these rather nice looking anti-vandal switches, for example. Also, the low voltage control means that you don't have a bunch of mains wiring running back and forth inside the chassis, which is really nice. Now it is time to get the amplifier modules mounted on the heat sinks. So basically we need to turn this into this. Both the amplifier module and the Guardian 86 mount to the heatsink. The amplifier module mounts to these 3 holes. If you're using the Modulus-186, you're only using these 2 holes. The Guardian 86 mounts to these 4 inside holes. And in case you're curious, the outer 4 are for the older revision of the Guardian 86. Those holes will be removed in an upcoming version of the chassis. These 3 holes are for the Modulus 86 because this chassis actually supports both Modulus 86, 186, and 286. Let's start by applying some thermal grease to the amplifier module. So you want to give this side of the amplifier module a thin coat of thermal grease. Basically you smear it on like so. Keep a rag handy because it's pretty messy stuff. Then what I do is I take the blade of a utility knife and I just smooth out this thermal grease. Ta-da. You basically need enough that you cover the surface roughness or the surface imperfections, and that's about it. Next, I will mount the amplifier module onto the heatsink. So that goes on with 3 4mm by 6mm machine screws, so M4 by 6. And I'll just place the module over the holes, and I'll start with the screw in the center. And I'll just get it started, and then add the other two. Just not even finger tight, I just basically want to get the screw started. Then when I tighten the screws, I start with the one in the middle. And then the two on the sides. Like that. So that's step one. Next step is to mount the Guardian 86. So I'll take these are short standoffs. They are about 5 millimeters in length. And I'll just place them over each mounting hole. Like so. And I will mount the Guardian 86 such that the output side faces the bottom. Then the output can just run under the amplifier module to the rear panel. And that attaches with 4 M3 by 10 millimeters long machine screws. Like that. Let's get this amp wired up. When you buy the Modulus-286 and also the 186, you will get a set of crimp leads like this where they have crimp terminals on both ends. You will get a set of connector pieces like this. The 3-pin here is for the power supply. The 2-pin is for the amplifier output. And the green guys here, sometimes I might deliver them in black, but they are for the input. So they plug into the input of the amplifier like so. And that makes it fairly straightforward to wire up the amp. So for this build, as I mentioned, I'm using the Modulus-286 with the Guardian 86 as the protection circuit. So the output of the Modulus-286 needs to connect to the input of the Guardian 86, and the output of the Guardian 86 is then routed to the amplifier output. The power supply for the Guardian 86 is taken from the Power 686. Let's start by making the wiring harness for the Modulus-286. If you look at these pre-crimped leads, you will notice that on one side there's this little tab that points out. And that needs to be aligned with this window here in the connector piece. So I just align the two like that and plug it in. And you hear a click. And now the connector is in. And let's do that a couple more times, like so. And now all I have to do to figure out is the length of the output wiring. So what I do is I plug it in to the output of the amp. And then I just route the wires over to the Guardian 86. I want them about like so. And just cut them to length. Like that. So I have the output of the amplifier connected to the input of the Guardian 86. The plus, amplifier plus output is marked with red heat shrink, and amplifier out minus is marked with black. I like cleaning up the wiring with a wire tie. That just makes it look tidy, and it might also give you a little bit better performance. One thing is that I like using bootlace ferrules on the wire ends, at least on the heavier gauge wire. And that's because I use stranded wire. So what can happen when you jam a stranded wire into a screw terminal like this is that the wire strands will sort of shift over time, and they might at some point have a bad connection. And the bootlace ferrules are pretty cheap. You can buy a set like this. It's about 30 bucks online, and it contains, you know, I think it's 2,500 pieces. And it even comes with the tool that is used for crimping the terminals onto the wire. So that makes for a nice and reliable connection that will last for many years. I now have the amplifier modules connected to the Guardians. And I also attached some power supply wiring for the Guardian 86s. On the left-hand side of the chassis, the transformer is going to go here, and then the Power 686 is going to go on the right side. So the wiring for the left side needs to be a bit longer. And the right side can be a bit shorter. So now let's grab the rear panel and the front panel and get this assembled into a chassis again. For that, you will need the 8 flathead screws that you removed earlier. Now it's starting to look a little bit like an amplifier. I have the chassis assembled, as you can see, or at least the sides, including the heat sinks. And on the bottom side of things, this is the 2 wires that are connected to the binding posts. They need to connect over here at the Guardian 86. So I'll cut them to length and apply the bootlace ferrules and connect it all up. And now the output of the Guardian 86 is wired to the binding posts. As you can see here, the output plus and minus of the Guardian is run under the Modulus-286 to the binding posts, and then from there to the Speakons. Space is a little tight behind the Speakon here, and that's just one of the compromises I had to make in order to squeeze everything into the chassis. And now let's get the inputs hooked up. The inputs to the amplifier are located here and here. And as always, I've left the cable a little bit long, so I need to trim it to length and apply the input connectors. As I showed earlier, I start by stripping off 20 to 25 millimeters of the outer jacket. Then I separate the shield using a scribe. Then I twist the shield wires together and clean up. Before I forget, I'll add this bit of heat shrink. That will come in handy in a moment. And I'll trim off the end of the shield, just so that I get a uniform end, or a flush end. Unlike when I soldered up the connectors on the rear panel, I will not be tinning the end, and that's because this goes into a screw terminal. So what's going to happen here when I cut these wires, or the shield here, is that all these wires are going to go everywhere. To prevent that from happening, I'm just going to cover the pliers with my fingers like that, and then I'll throw the wire bits in the garbage. Okay, so now it's time for the input connector. I'll start by adding a little bit of heat shrink. That much is about right. Then I will strip the wire ends here. Twist the strands together. And I then like to fold the wire over. Like that. That gives the screw terminal quite a bit of wire to clamp onto. Then I just grab one of the screw terminal. Pin 1, 2, 3. Pin 1 goes to the shield. So let's get that connected up. Like so. Now I just need to shrink the heat shrink and repeat for the other side. When assembling the bottom panel, I like to start with the grounding lug. That goes right there. It attaches with an M3x6 and a M3 lock nut. Next up are the 10mm standoffs. And by the way, all this hardware is included with the chassis if you buy it from me, so you don't have to worry about sourcing it elsewhere. But anyway, the 10mm standoffs, you'll need 8 of them. And they go, let's see, here for the power 686 and here for the ISS. Like so. Now it's time for the feet. I like these solid aluminum feet from Takashi. They're a little bit expensive, but they're pretty nice, and certainly much nicer than the stick-on feet that normally comes with the chassis. So these are included when you buy the chassis from me. They attach with M4x12s and some M4 lock nuts. Like that. When placing the Intelligent Soft Start, or ISS, and the Power 686 on the bottom panel, you have a couple of options as far as the rotation of the board goes. The ISS should be placed such that the primary wiring to the transformer is as short as possible. So that would be about like so, like I have it here. Then for the Power 686, you basically have two options. One is like I've shown here, where the input side is here, the rectifier diodes are on this end, and the output side are up against the front panel of the amp. Unfortunately, that also places the rectifiers right next to the input of the right channel, and I don't think that's particularly optimal because the currents that flow through these rectifier diodes can be pretty high, and they're also at the same time in the form of current pulses. So I would prefer that the Power 686 is rotated like so. Unfortunately, for this particular transformer, that means that the wires aren't long enough and I'll have to extend them, but that seems like a small price to pay. The second price to pay is that the on indicator LED on the Power 686 bumps into the front panel, and that's no good. So I'm going to modify that a little bit. Basically, what I'm going to do is I will remove this connector for the LED. I already have a power on indicator for the ISS anyway that's integrated into the power switch, so I'll just use that instead. The modification of the Power 686 is very simple. All you have to do is to connect the two pins on the LED connector together. Like that. Next up is the power transformer. This one is a 300 VA type. It provides two windings of 25 volts AC, and it has an international primary. You don't have to go with an international primary. I do it so that I can sell my amplifiers worldwide without having to swap the transformer. It mounts in the chassis with an M6 by 45 millimeters long machine screw, or hex bolt in this case. The bolt is not included with the transformer, so you're going to have to swing by your local hardware store to pick one up. Alternatively, if you're in the US, the Antec brand of transformers works quite well and is very affordable. The main drawback of the Antecs is that they tend to use 3/8 inch diameter mounting hardware. So that's about 10-ish or 8 millimeters, something like that. And this hole is 6.4 millimeters. So you're going to have to drill that up if you use the Antec hardware. Otherwise, again, swing by the hardware store and pick up an M6 instead. When mounting the transformer, I start by feeding the mounting bolt through the hole in the chassis bottom. Then this rubber washer goes on there. That comes with the transformer, and it just prevents the transformer windings from being jammed right up against the chassis bottom. And then the transformer itself, like so. And I turn it such that, as I mentioned, the wiring is as short as possible. And then I add a flat washer, a lock washer, and a regular hex nut. There we go. And then just tighten. And as you can tell, there is a yellow-green wire coming out of this transformer. That is for the electrostatic shield. That sits between the primary and the secondary, and the intent of that is to shunt any RF or high frequency energy that's present on the mains to ground. So that needs to be grounded, and ideally with as short a wire as possible. And conveniently, there is a mounting screw on the ISS right here. So I have attached a solder lug to that, and then I will trim the wire to about this length and solder. Next up is the primary. So there are two primary windings on this transformer. Each is 117 volts. And that's a pretty good compromise to be able to reach all mains voltages used worldwide by either putting these windings in series or in parallel. So the two windings are marked with different wire colors. So you have purple and blue, and the phase of the winding is marked with this yellow band. So that part is easy. I don't care so much for the fact that these are tinned, so the wire ends have solder on them, because when you jam a soldered or a wire with solder into a screw terminal, the pressure of the terminal will cause that solder to get smushed. And over time, it basically, because solder is a bit malleable, that wire will come loose. So I'm going to cut the ends off and put bootlace ferrules on instead. Like so. And from here, it's pretty easy to connect the primary to the ISS. I'll grab the purple wire that's marked with the phase mark, and I'll connect that to terminal 4. Then the purple wire without the phase mark goes to terminal 3. Then the blue wire with a phase mark goes to terminal 2. And finally, the blue wire without the phase mark goes to terminal 1. And that's all there is to it. Now I just bundle these together tightly with a wire tie, and I'm ready for the secondary. I have the wires of the secondary organized in the order that they emerge from the transformer. It's clear that white goes with white, that's one winding, black goes with black, that's the other winding, but the phase is not indicated on the wires. So I'm going to assume that the first wire that comes out is phase, the second wire that comes out is null, and then the third wire that comes out is phase, and the final fourth wire is null. And I have indicated the phase with the red. So what you want to do is basically connect terminal 1, 2, 3, 4 on the input to the Power 86 to wires 1, 2, 3, 4. Like that. Now all I have to do is to make sure that these wires don't interfere with the front panel. I might have to bend them back a little bit and generally tidy it up with some wire ties. Like so. And now we're basically done with the power supply. All I have to do is connect the mains to the input of the ISS and the power switch to the control connector, and this power supply should spring to life. I prefer that the mains wiring is double insulated. So I have draped the mains wiring here in heat shrink. I've also trimmed them to length and added these bootlace ferrules. So now all I have to do is connect them to the input of the ISS. And that happens on this connector right here. And let's see. Neutral and live are marked on the board. Neutral is towards the corner. Neutral is white, so I am going to put the white wire in there. The live wire is then towards the center of the board. Like that. And now let's hook up the power switch. So I've already trimmed the wires to length. All I need to do is hook them up to the proper terminals on the control connector of the ISS. Now I have all the low voltage connections made to the ISS. I have the trigger connected at the trigger input, power switch, and power on and standby LEDs connected over here on the low voltage control connector. So this allows us to test the power supply. And I highly recommend that you test the power supply before you connect the amplifier modules, because if there is a problem with the supply, that it for some reason puts out too much voltage or whatever, that it can be a really expensive mistake if you just wire it all up in one big bang test. So let's test the power supply separately. Before we can test the power supply, we need to install a fuse. That happens in this fuse drawer right here. That's part of the IEC inlet. If you notice, there are two compartments in it. There's one compartment that's towards the outside and one towards the inside. The one towards the outside is a storage compartment for an extra fuse. So the fuse goes in the compartment on the inside. So just pop that in and slide the drawer in, and that's all there is to it. I recommend that you size the fuse according to the VA rating of your power transformer and your mains voltage. So I use the VA rating of the transformer divided by the mains voltage as a starting point for selecting the fuse. I typically go 10-20% higher than that, just to make sure that the fuse doesn't blow unintentionally. And it needs to be a time delay fuse, otherwise it'll blow on startup. So in my case, I have a 300 VA transformer and 120 volt mains. So a 300 divided by 120 is 2.5. And then I go 20% up from that. And that got me to a 3.15 ampere fuse. That was the closest standard value. Before we can plug in the mains, we need to select the appropriate mains voltage on the ISS. That happens on this white connector right here. With the ISS, you received this little baggie with a couple of wires and a connector piece. That needs to be configured according to the design documentation to select the correct mains voltage on the ISS. With the jumpers configured for 120 volts, I'll plug it in to the white connector. Like so. With the ISS configured for 120 volts, I can now plug in the mains. Ta-da! Get a red light on the front indicating the amp is in standby, and no sparks, no fireworks. Life is good so far. I will now turn the amp on. I'll get a gentle hum from the transformer and a click from the relay, and the light on the front turns green. With the power applied and the amp turned on, I can now verify the output voltage of the Power 686. I do that by taking the negative probe of my voltmeter, putting that on ground. That would be any of these two terminals here. And I'll then take the positive probe of my voltmeter and put that on V+, and that would be any of these two terminals here. So I'll just use this one. And I get 37.8 volts. That might sound a tad high, but that's about what I'd expect when the power supply is running without load. So now it's time for the negative voltage. I'll just swap hands because otherwise you can't see. And I'll take this negative probe and put that on ground again. And then take the positive probe of the meter and put that on V-, and that's any one of these two terminals here. So I'll just use this one, and I get minus 37.8. So I have plus minus 37.8 volts coming out of this power supply. And like I said, it's a bit high, but not dangerously high, and it's about what I would expect when the power supply does not have the amplifier modules connected to it. One of the most common mistakes people make when they measure the output voltage of the Power 86 or the Power 686 is that they connect from V- to V+. So that would look like this. And in that case, they look at the voltmeter and they go, it's 75.6 volts, and that's way more than they expected. And that's simply because they measure the total voltage across the entire power supply, not across each half of it. So actually 75 volts for a plus minus 35 volt power supply without load is quite reasonable. Now I'll turn the amplifier off, unplug the mains, and wait for the capacitors to discharge. Now what we have left to do is to hook up the power supply to the amplifier modules and the Guardian 86s. So for the amplifier modules, you need the 2 3-pin wiring harnesses that we made earlier, and for the Guardian 86, that's what these two wires are for. So when hooking up the amplifier modules, you have basically two choices. One, you can use these power supply harnesses. You will have to use this end of it anyway, but you can use the other end as well. If you buy an extra set of these white connectors from DigiKey or Mouser, you can make a 30 centimeter harness like this. The drawback is that it is 30 centimeters long because that's the only length that's available of these pre-crimped leads. So for the amplifier on the left, it's only slightly long, but for the amplifier on the right, it's quite long. So there are a couple of options for how to deal with that. I mean, you could easily just coil it up and tie it off nicely with a wire tie or something like that. You could also cut and splice the wires so you make shorter wires. Finally, you can buy these crimp terminals and make your own crimp. I don't recommend that just because it's actually kind of difficult to get a good crimp with these terminals. It can be done, and you can certainly hack it with a pair of pliers or end cutters and just solder or something like that. A second option is to use the business end of the power harness as we've already made it, and then route the wires into the power supply and use these terminals. In that case, you will find ground on one of the two terminals in the middle. You can use either one. They're indistinguishable. And then plus is on these two terminals and minus is on these two terminals. What I will do is I will actually get that extra connecting piece, and I'm going to use these two connectors right here. That's exactly why I put them there, so that the Modulus-286 and 186 become plug and play. The wiring harness comes together pretty easily. You have to connect pin 1 to pin 1, pin 2 to pin 2, and pin 3 to pin 3. So that's actually fairly straightforward. To make it a bit easier to see in the video, I have color-coded the ends of the wire with colored heat shrink. It's a little too big, so it unfortunately slides around a little bit. So bear with me on that. And basically the deal is that if you have the connector oriented like this with the locking tab facing down, the other locking tab like that, then the blue wire needs to connect to this pin and to that pin. The red wire connects to this pin and that pin, and the black wire goes in the middle. So let's do that. These terminals have a locking tab, and that needs to engage with that window in the connector. So I stab it in like so. Come on. There. And then do the same for the ground and the same for the plus. Get in there, like that. And let me just show you what that looks like. So now, if we hold the connectors with the same orientation, the wire should connect like this. And now with two of these harnesses made, it's almost literally plug and play. So I will start with the left channel. I click in the connector like that, and then connect it on the other side at the power supply. So I have a little cleanup to do here. That's no big deal. The second harness I will plug into the power supply like so, and then plug into the amplifier module. So now all I have left to do is a little bit of tidying up with some wire ties, and we're ready to hook up the Guardian 86. Like that. Now it's time for the Guardian 86, and as usual I will trim them to length, trim the wires to length, and apply the bootlace ferrules and get them all hooked up. Now the amplifier is all wired up. I have the power harness from the Guardian 86 on the left side running here. Red is V+, black is ground. Red connects here to V+, black connects to ground here. On the right side, red is V+, and connects to V+ here. Black is ground and connects to this ground terminal in here. Some might argue that you should braid the power supply harness, but that's really not necessary, and in fact it might do more harm than good. The main point is that you want the power supply harness to be tightly coupled. So basically take the 3 wires and make a bundle like that, and then hold them together with a zip tie. That's all there is needed. Now all we have left is to test the amplifier before we put it into service. I have a separate video on basic amplifier testing that you can find on my channel. The amplifier tests out to my satisfaction, so now it's time for the top cover. That goes on with 6 oval head machine screws, and I use the fancier ones from Takashi with the torch drive. Just be a bit careful because a screwdriver slip is likely to scratch the top panel. Like that, congratulations on a build well done. If you found this video informative or helpful, please make sure you click like and subscribe. And better yet, if this video has inspired you to build one of these amplifiers for yourself, go on to Neurochrome.com and order your Modulus-286 today. Thank you for watching.